Alright, what is up everybody? I'm back with another video, and in today's video we're going to cover a product state graph question. So as you can see here, we have two equations, you could say, one on the top horizontally and one vertically, and these are two FSMs, and we're going to combine these two FSMs through product state graphing. Alright, so let's get right into it. So if we analyze the top FSM, we have number 0 actually, I should say, number 1 and number 2. And we have at number 1, when x is equal to 1, it goes back to itself. When x is equal to 0, actually, let me just get rid of that mark here. I think I may have made that. Right, so we have at number 0, when x equals to 1, it just goes back into itself. When x equals to 0, it goes to S1. But at S1, if x equals to 0, it goes back to S0. And at S1, if x equals to 1, it goes to S2. But if S2, if x equals to what value does it go back? All right? So one thing we can realize from the top right here, what is this d value and how do we find it? Logically speaking, we see that if x equals to 1, it goes forward from S1 to S2. Now, we know that it has to be x equals to 1 to go back. Because if it was x equals to 0 to go back, it wouldn't make any sense, because if x equals to 0, it would end up going all the way back to the beginning, because if x equals to 0 and it went back to the middle one, this value would be 0, and if this value is 0, then it would go all the way back to here, which is S0, because the zeros would just continue on all the way through. The reason why it has to be x equals to 1 is that if it's x equals to 1 over here, that means then the x equals to 1 would then come back over here. The only way this goes forward if it was x equals to 0. If that doesn't make sense, please comment down below, and I'll make sure to make another video on where we have to make the top and horizontal vertical FSMs when we do product state graph questions. But we can determine that this value x equals to d must be x equals to 1. Because if it was x equals to 0, if x equals to d was x equal to 0, this line would not come back to S1. It would always go back to S0 if it was x equals to 0, if that makes sense. So because it's x equals to 1, we can determine that it's x equals to 0 as it goes back. Right? So now that we figured out x equals to 1, and we know this if this is S2, if x equals to 0, then it's going to go forward through the product state graph. Now, if we look at the bottom, we have position 0, and if x equals to 0, it goes back to itself. If x equals to 1, it moves forward to position 1. And if x equals to 0, it goes forward to position 2. At position 1, if x equals to 1, it goes back to position 0. And at position 2, if x equals to d, it goes back to position 1. Now, it's the same thing as it was on the top. X equals d must equals to x equals 0. And this is because if x is equal to 1, then it wouldn't go back to position 1. If x is equal to 1, then it would go all the way back. If x is equal to 1, then it would go all the way back to position 0. Now, this makes sense because if x is equal to 0, it would go back to position 1. But if x is equal to 1, because there's another x equals to 1 over here, then if x is equals to 1, this will go all the way back to position 0. And because the line doesn't go all the way back there and it only goes to position 1, we can assume and determine that x is equal to 0 and this d value over here is 0. Okay? Now, knowing that, let's see what we can do to fill out the state graph. Now, for every single state graph in this top left corner, in every single state graph, it's always going to be the same. It's always going to be P0 and S0 connected with one another, because they have to have a starting point for every state graph, right? So this is always generic for every state graph. In the top most left corner, it's going to be the first position of the vertical and the first position of the horizontal. So we're going to have P0 and S0. Now, let's start with the S0 FSM first. So how to do product state graphs, So if we see here, let's do the forward ones first. So x is equal to 0 and x is equal to 1. So from position S0, when x is equal to 0, it becomes S1. So if x is equal to 0, we know that it's going to go into the second column, right? Because this is where S1 is in the second column. Now, where vertically is it? If we go at position 1, if x is equal to 0, it stays in the same row. So then, therefore, we have that position 0 and S1 is labeled here. And we have when x is equal to 0, right? So basically, we're using coordinate systems. So at S0, when x is equal to 0, it goes to position 1, S1, which is the second column. But x is equal to 0, when P0, x equals 0, it stays in the same row. So we get 0, 1, basically, as a coordinate system. Now, when we're at S1, we get x equal to 1 to go to position 2. Or S2, I mean. So S2 is going to be in the third column. Now, when x is equal to 1, from position 0, when x is equal to 1, it goes down to the second row. So then we can determine that over here, we get P1, S2, because it lines up with the second row, which is P1, and the third column, which is S2. So we get a coordinate system, which is 1 and 1 over here. So we get x is equal to 1, right? So that's for the FSM state graph, right? Now, let's do for the position state graph. So when we have P0, when x is equal to 1, we go down to the second row. When x is equal to 1 here, we see that S0 stays in the same column because S0 doesn't move forward. So when x is equal to 1, position goes down to the second row. So we're going to have a circle here, but it stays in the same column because S0, when x is equal to 1, it does not change. So we have P1 here and S0 when x is equal to 1. Right? When x is equal to 1, we get P1 and S0. Now, when we're at P1, we see that when x is equal to 0, it moves forward to P2. So we're in the third row now. So when x is equal to 0, we move forward to P2. But when x is equal to 0, from S0, we go to the second column. So we end up having a circle here. So the second column, third row. And then we end up having a circle here. And then this is when x is equal to 0, which is P2, S1, right? So if we look at this circle here, when P1, x equal to 0, it goes down to the third column. And then from the top, which we're in this S0, when we're at the S0 point, when x equal to 0, it goes to the second column. So we get the second column, third row, and that is our bubble with P2, S1. So now we have all the forward ones, but now let's do backwards. So if we start over here at P0, S1, right? At P0, S1, what number do we need for P0, S1 to go back to P0, S0? It said when x is equal to 0, it goes back to the starting position. So we're going to draw a circle backwards over here. And we're going to put when x is equal to 0, right? Now when we're at S2, how do we go back to S1? And we determine that it's when x is equal to 1, right? So we're going to draw another line back to the second position, which is x is equal to 1, right? Now let's start with the P position vertical FSM state graph. So when we're at P1, how do we go back to the original when x is equal to 1, right? So if this is the original circle, we start with the second circle and we go backwards when x is equal to 1. Now if we're at the third circle, how do we go backward to P1? Then we go from P2 to P1 when x is equal to 0. Is that what we determined? So we start from this circle and we go backwards over here when x is equal to 0. Now we're missing two more lines. There has to be two lines connecting one from here and one from here to complete our full circuit of product state graph, right? Because it has to be a circle. So what are those two lines equal to? What is this x equal to and what is that x equal to? So let's start off first here. So if we go from P2 to S1, how do we go from P2 to S1 to P1 to S2? Well, what value do we need? What value comes into P1, S2? We get x equals to 1 entering P1, S2. So that way we know that x equals to 1 has to come from here to here. From P2, S1 to P1, S2, x equals to 1 has to be the value that enters it. And because we know that x equals 0 goes backward, x equals to 1 is the only thing that can go forward, right? But where does it go forward into? That's when the product state graph comes in. So we can determine that because x equals 0 is backwards, there's always two numbers associated with the bubble, right? So we have x equals 0 going backwards, that means x equals 1 has to go forward. So that means x equals to 1 goes forward here because it's x equals to 1 that enters S2, right? So x equals 1 enters S2, so another x equals to 1 can enter P1 S2 as well. Now when you go to P1 S2, we have x equals to 1 going backwards, so we know that x equals to 0 is the one that needs to go forward, right? And now we can see here for P2, x equals to 0 is the one that enters P2. So then we could determine that 0 can enter P2 S1, and then P1 S2 has a 0 coming forward, so we can just connect those, and we can get x equals to 0 over there. And this right here is the finished product of the product state graph that we have drawn out, and the correct solution, right? So as you can see, it's pretty simple, straightforward. I would suggest the best strategy to completing these questions is to always start by going forward. So do the forward ones first, so x equals to 0, x equals to 1, and then you do the forward ones for the vertical one, which is x equals to 1 and x equals to 0, and then you work your way backwards, right? Because the backwards one are pretty simple, and then you only have to figure out the last two lines that connect it to become a full circuit, right? So I hope you guys enjoyed this video. If you understood and enjoyed it, please make sure to like, comment, and share, and also subscribe to the channel. As we're going to try and touch 1,000 subscribers by the end of the year, as that's the goal. So please make sure to like, comment, and share. If you have any questions or concerns, please make sure to comment down below. And if you have any other specific questions or topics that you want me to cover, please make sure to comment down below or share a link through the comments, and I'll make sure to make a video on it as soon as possible. Alright, thanks for watching, guys.